back from Europe. It's been a case of integrating the Triumph into our Dyno car, getting the engine running and finding a nice map for us to then build CR13. So currently we are in the final stages of design. All the fourth years are tasked with designing the car, obviously. Different teams, chassis, engine, aero and so on, they're all coming to the end of it. So we're looking, hopefully, to start building the chassis by the end of this year. As far as design progress, we are probably 95% there. Designs are still being validated and there's still a little bit of work to be done, but there is essentially a car. Let's go have a look and see how the design's going on.
So to start the design, we start with a couple of main parameters. Primary of which is that we need to create a nice, safe driver cell, which is safe according to the rules. We also need to house the engine and, of course, have the wheels mounted stiffly to the chassis. To do this, we created a concept design of what we wanted to see roughly this year, how we could save weight, how we could increase the torsional stiffness, and then from there we passed it on to engineers like Tom, who looked at simulating the chassis to try and make it engineered to be stiff and light. So the regulations define areas such as the area we have for the legs of the driver, the area we have for the cockpit opening template. We also have regulations that define how far the helmet can be from both of the roll hoops and how far within the roll hoops the driver's helmet can be. So in order for the chassis to be legal for the driver, including his or her helmet, the chassis template, known as Percy, which is provided by the rules, has to be at least 50 millimeters away from a line drawn between the top of the roll hoop and the top of the front roll hoop here. So the sketch you can see here is actually the minimum we're allowed. So the area bounded by these two here, anywhere in here is legal if the main roll hoop is there. So as you can see, we've got plenty of legality for the Percy model, which is here. And the reason there's another helmet a little bit lower is because we also need to accommodate a 5th percentile female. So this defines things like the positioning of the headrest mount, which you can see here, and also the roll hoop.
So what I've got on my screen here at the moment is a model of the monocoque and the space frame. So we create this using the CAD dimensions on SolidWorks. We then import the points using the XY coordinates, connect up the points and then assemble the car basically. So the benefit of using Patran is that once we've imported the geometry from the CAD file, we can use a validated guide developed by last year's Cardiff Racing chassis team to get a value for the torsional stiffness of the car. The benefit of finding this out is that torsional stiffness is an important characteristic for a car as it relates to the vehicle's capability of lateral load transfer. So ideally you'd like a high torsional stiffness, as this means that the suspension can work more effectively and more predictably. So to gain a torsional stiffness value for the car, you need to apply a torque to the rear of the space frame. This is done by applying 2 vertical forces, one downwards and one upwards, both on the wishbones. The distance between the 2 points of application is known. We then apply this into the spreadsheet which was developed by last year's chassis team to then compute a torsional stiffness value. So once you've applied the loads, you run the simulation and you can plot the deformation. So this gives you a rough idea of, obviously it's done to a scale, but this is what how the car will behave with the torque applied to the rear of the space frame.
So by looking at plots like this feeds back into the design of the car. We can look at where the tubes are most highly stressed and then make them slightly thicker on the design we want to use, or look at where they're very lowly loaded and make them even thinner to save mass.
So these 2 engines are the transition period we're going through at the moment. So this is an Aprilia that we've used for many years now. It's almost 8 years old, and it was a brilliant engine. The power you get from it is brilliant, and it's extremely light. We're moving to this beast mainly for reliability, but also because this gives a lot more power. It's a 3-cylinder compared to a 2-cylinder. It may be heavier, yes, but it will be more reliable. It does have an included oil cooler, and with more reliability means more finishing, means more points. So hopefully in the future we'll compete and be more competitive than we have been. We've had great support from Triumph this year. Our engine team lead came from Triumph. He's the main reason we have the Triumph engines. They've been brilliant in supporting us with design data, so we can actually make a car designed exactly for this engine right now, opposed to learning as we go and keep on iterating until we're at the point where we can be ready to integrate it with our car. So as part of that development we've needed to do with the Triumph engine, we've somehow incorporated this engine into one of our old chassis. That's no means feat, it's quite a difficult task. We now have a car that runs with an engine that we've completed in almost 2 months. The whole reason we've done this is so we can go and take it to a rolling road or a dyno and actually measure the power outputs and make sure everything runs specific for us. So now we'll go to the dyno and see how it goes.
So we're here at Owen Developments to go get our engine mapped. We are working on the calibration fact and trying to get a power figure out of it, working on ignition timing and our fuel injection ratios. We saw on our first run power around 75 horsepower at the wheels, which is a great improvement for us over our Aprilia, which we think we made about 55 horsepower, so we're really happy with that. So what happens next? We're a bit more fiddling, a bit more tuning of the map, and we'll see how high we can go. We're really happy with the progress that we made today. Thankfully, here at Owen Developments, we've managed to get a full tune of the engine. It runs really smoothly and really smooth, especially on our new fuel using E85. From that, we managed to get a full power run, and we saw around 88 horsepower, which we're really happy at. So it's going to get a good stance to get going for the next car. More so than that, we managed to get a nice flat torque curve, which is brilliant, which is perfect for the sort of circuits we do, where they're small, twisty, and not necessarily based on outright power in the straights. So we're really happy with today, and hopefully that's going to put us in good stead for development for the next race in Silverstone. What happens next? So we've got all our data ready to go. We're going to look over that back at base, back at the Cardiff. Look over those, make sure we can design some of the components that we need to do around it, such as the plenum and the exhaust, to suit the data that we've gathered today. And all being well, then we're going to return here in around 4 months' time, where we're going to do another power run just to do a final tune for the new exhaust system and the new plenum. And hopefully we'll be all set then for Silverstone. So after bringing the Aprilia here last year and having it spill its guts all over this dyno, we decided it'd be best if we put the Aprilia to sleep.